Hi everyone, welcome to STRV. My name is Daniel. I'm a front-end department lead at STRV and I'll be your host for the next hour. For those who don't know, STRV is a software and design company working mainly for clients in the US, and we are based in LA, and we do have an office in Prague too. And we are right now in that Prague office doing this live stream for you. As I said, I'm leading the front-end department, and front-end department at STRV consists of 20 engineers, mainly focusing on React and React Native. And one of those engineers, Aron Berezkin, standing right here, has prepared quite an interesting topic that I believe you will enjoy. Before I give my word to Aron, just quick organizational stuff. I'll be the whole time behind the camera, so whenever there's any question, please feel free to ask. I might jump in and help Aron to answer that, but also mainly after Aron wraps up his talk, I'll come back to the stage and we're gonna run a short Q&A depending on how many questions you guys gonna have. I believe that's it from my side, and I'm passing my word to Aron.
Thank you, Dan. Welcome everyone to my talk today about biometrics and its implementation in React Native, even though the approaches I'm going to show are definitely used also by Android and iOS native engineers. I'm going to start with going through a small walkthrough what we're going to discuss today. First, I'm going to just kind of introduce myself, say a few words, then we're going to have an intro about biometrics so that we are all on the same page. And then we will go to the technical part of the presentation. We will be discussing different criteria we have to consider when we are implementing biometrics in React Native. In React Native, we have to find solutions for both Android and iOS, so various criteria are important so that we find the right solution. And then after that, I'm going to be actually talking about the solutions, about the different implementations. The first one will be mobile-only implementation, where we will don't need any backend, so I'm actually going to show a small demo so that you understand how the flow works. Then we're going to move to the second implementation, which will be backend implementation, more focused on security. And finally, there will be third combined implementation of the previous two, which will be kind of a practical approach using refresh tokens. Finally, we will summarize the talk with some UX guidelines, how to implement biometrics so that users have great user experience. Maybe a topic for designer, but as a developer, I believe those are important for us to understand as well. So without further ado, let's go and chat a bit about me. My name is Aron Berezkin. I started in STRV in August 2019 as a front-end developer. Previously, actually, I worked in financial markets sector, pursuing career in London, working for Bloomberg. But that is in the past. I decided to change career when I turned 30. I wrote an article about it. It's on a STRV blog, or you can just click through the presentation. Then 1 year later, I actually was approached by Dan if I want to try a native project. So I jumped for this opportunity and actually also have written an article about it, how to basically transform from a web developer to a React Native developer. And actually, you can also find them on my blog, which I just started. So please wish me luck. One final shameless plug. If you want to have the cool hoodie, as I do have on the photo, STRV is actively hiring, so definitely go to the website, and we are looking for all kind of engineers. So let's start with biometrics. When we talk about biometrics, usually in the mobile terms, we chat about Face ID, Touch ID, and in case of Android, they call it fingerprint. And previously, we actually had also iris recognition, which Samsung introduced for some of their Galaxy phones, but this is not used anymore, so we can get it out. So in simple terms, under the biometrics umbrella, we can put the Face ID and Touch ID or fingerprint, but I would mention that Apple, I would say, doesn't embrace the biometrics label. They like to talk specifically either about Face ID or Touch ID, while Android is generally talking about biometrics, maybe because previously they had also the iris recognition. And you can see that iOS labels the fingerprint Touch ID, while Android is always labeled as fingerprint. It's important because Apple actually in their guidelines, they explicitly say, hey, if your device supports Touch ID, say that you are enabling users for Touch ID, and when it's Face ID, mention Face ID, so that the users don't get confused. So this is pretty much it. We can now go to the considerations when we implement biometrics. It's an important step because, as I mentioned, in React Native world, it's not always easy to find the best solution that works both for Android and iOS. What I actually call it is due diligence. It's a term I was quite familiar with in my previous financial career. Due diligence is basically when one company wants to acquire another company and they conduct audits so that they understand that the financials and the company's business is really what the company says it is. So I feel like whenever I start to implement something in React Native, I conduct this due diligence. I have to investigate if the libraries I'm going to use will give me what I want to actually implement. It's very hard to maintain these libraries for both platforms, so it often happens that certain solutions fall behind, and that's why you have to do your own due diligence. And there are a few criteria we have to consider specifically with biometrics. The first one is security. Why security? Well, usually you will find biometrics implemented in mobile application of your bank or either company, maybe Coinbase and such. Why they do it? The reason is because whenever you log in, they will give you very short-term access to the application, maybe 5 minutes, maybe 10 minutes. Maybe in some cases, whenever you put the application in the background, they will already end your session. And to kind of get you back to the application, they will use biometrics. Why they do it is because imagine someone steals your phone and there is an active session for a very long time, so they can just turn on your application and maybe steal some money, send the money somewhere, maybe steal just your details. And that's why they have to always give to the users very short-term access. And with that goes also user experience. Because imagine a user which has to log in every time they just go in background and then they turn on the application again. They would have to input the username and password. It's very non-practical, right? So you want to make it easier for them, and that's why you ask them for biometrics, which is their way to authenticate. On my previous project, our client was, for example, already cost sensitive, so they decided to release their financial application without the biometrics. And obviously, the first feedback they heard from the users was, why do I have to input my email and my password every time, or in case of this application, every day when the session ends? And that's why the biometrics is always there to provide a good user experience. But here I'm actually talking about user experience in case of React Native ecosystem when you go to search for a solution. So it often happens, as I mentioned, that some libraries get maintained, and that's why you cannot, in some cases, offer the solution the native users would expect. So let's say we have Face ID, and it's quite often used, let's say, when the Face ID doesn't work, maybe you have a respirator on your face these days, you can fall back to your device passcode and basically authenticate yourself this way. But imagine some of the React Native libraries are not on top of this biometric standard, and they cannot offer the fallback to passcode. And that means that you have to sacrifice this user experience. And it's not always something what you want to do, right? Because the users expect a great user experience from your application. And the final criteria is obviously the development time. And it touches the previous criteria, because if you cannot offer with the library what you want, maybe you have to decide for some custom solution, but the custom solution will take some time to implement, and maybe your client is very cost sensitive and they don't want to go with a custom solution. And that's why, again, it kind of narrows down the solutions you have available when you're implementing biometrics. Obviously, if you have any questions during this presentation, you can ask, and maybe Dan will let me know, or maybe we will leave it for the end of the presentation. So let's go actually to the implementation. And here I prepared 3 different approaches. The first one will have a demo, so let's get to it. Before the demo, I will just share some information. So this is a mobile app implementation. This means we don't use any backend. Basically, all the logic of biometrics lives within the mobile application. The flow is pretty simple. The user just logins or signs up, and the credentials, the username and passwords they input, we securely store on their mobile device. In case of iOS, we store it in keychain, and in case of Android, we store it in keystore. And we can set that we store these credentials behind biometrics. And then when the session expires and the user wants to get back to the application, then we will ask them for the biometrics challenge to pass. And this way we can retrieve the username and password and basically use it the same way like we would use it in a login form. We just send a login request to our server with the credentials, and the server, the backend, returns an access token for us, and the user is free to use the application. So I would talk about the advantages of this approach, and then we will go to the demo. So the advantage is that we don't need backend. So it means we can, as front-end developers, implement it very quickly. Obviously, it's very cost-effective for the client. And another advantage is that this solution is readily available actually through this React Native keychain library. It's a well-maintained library that allows you to securely store various credentials and use basically various criteria how the user can access them, for example, using the biometrics. So now we will go to the demo of the implementation. So I will ask my technical assistant to help me changing the screen. And now I'm gonna jump to my coding editor and actually to my screen. So at the moment you are looking at my device, my real device. I have some backend implementation that will kind of approve this request. And when I click sign up, I'm gonna get into, let's say, the dashboard, the main application. So now what happens is that we saved the credentials of the user to the device. The device knows about the username and the password. So when we expire the session with the button, we can actually kind of mock the biometrics. So I expire the session, and then I have an option, login with biometrics. I log in with biometrics, and you might have not seen it. It was very fast, but the device scanned my Face ID and basically refreshed my session. So I'm gonna expire the session again and log in when the Face ID is not facing me. So you see what's happening. So it didn't recognize my face. I can try it again. It's gonna again. And then you see it gives me the passcode as a fallback. So I can just put there my passcode, and I'm gonna get again authenticated back to the application. So this is actually the React Native keychain library in action. To see actually its feature, we can maybe do some interesting stuff with the Face ID. We can maybe just reset it and see how the application is gonna behave when my biometrics change. So I reset the Face ID. I'm gonna set my Face ID again. Now you're gonna see me very closely. I'm gonna do some stretching. And one more time. Definitely good stretching for a developer sitting behind a computer always. So now my Face ID is there again. So let's see what our application will do when we expire the session. So if I log in with biometrics, you see it doesn't ask me for the Face ID. It already fallbacks to the passcode. And the reason is because the implementation of this is that whenever the biometric changes, the credentials cannot be retrieved by it anymore. Imagine someone would scan their face and they could access your credentials. That's probably not something what you want to do. To basically start using my Face ID again, the application, basically we have to wait for the moment when the user inputs the credentials, when they do the login or, when they do the login, yeah. So if I put the login now, so what happens after the login is that I'm gonna be saving the credentials again, but this time under my current biometric set. That means under, let's say, the new face, even though it's with me, it's kind of different biometric ID. So I expire the session and log in with biometrics, and the Face ID works again. So this was a quick walkthrough through the device, but let me go to the code just show that you understand how the implementation is from the code perspective. So we are utilizing this React Native keychain library, and during the sign-up we use this method set generic password. So when we call the sign-up, we get email and password from the user, we send it to the server here, and if the response is okay from the server, we can set the generic password to the device. So we set the email, the password, and then we have certain kind of criteria under which we want to save it. In our case, it's just, we have some identifier, which is a login service, and this is the important part, the access control. We set it to biometric current set or device passcode. Pretty much what we saw. So the current means that whenever the biometric, in case of Face ID, changes, it's not going to work anymore. But the fallback for passcode we want to use as well. Actually, we can use the power of TypeScript and see what options we have from the library. So there is application password, which means some custom password of yours. You can use biometric NA. We have the current keyword. That means that even if the biometrics changes, you can still access the credentials. You can use just your device passcode or user presence, which I believe is just when the user kind of is within the application. So that's the library. If we go to the login, so when the user logins with the credentials, we do pretty much exactly the same thing, server, and then we save the credentials. But the important part is when we logged in with the biometric button, so we check if the user has expired session. If they don't have expired session, we just do nothing. But if their session is expired, we access their credentials through this method from React Native keychain library, get generic password with, again, the setup we use to store them. And if we get the credentials, we just do the login request to the backend, and the backend returns us an access token, and we can freely use the application. So if you look at it, it's super simple. As far as biometrics is concerned, it looks very complex and too cool to be easy to implement, I would say, but in reality, it is quite easy to implement in case of this implementation. So now I'm gonna ask my technical assistant. We will go back to the presentation. And we talked already about the advantages, so let's continue and talk about the disadvantages. The clear disadvantage of this, and some of you might guess it, so maybe I will give a second if someone wants to try and have a guess what is the disadvantage of this solution. I will ask Dan if we get any responses.
1, 2, 3. There's no response, so I guess you can continue.
Okay, so well, the disadvantage is that we are having some security concerns with this implementation, because what we are doing is basically we are storing the credentials on a device, which is not the best practice. If you can, you would like to avoid storing sensitive data like username and password on the application, especially if your application is very security sensitive. If security is not concerned for you, obviously you don't have to care about this disadvantage. And then let's go, okay, not yet. Oh, this is very important actually. The library mentions that older Android devices, so even though we would feel it's securely stored, the older Android phones running on Android 6 and lower, well, running lower than 6, well, the credentials could be easily read when someone roots the device. Something you would like to avoid. That means in React Native you have two options. You can either read the operating system of the user and disable this feature for those that are on the old Android devices, or maybe it's quite common, I would say now, just to make the application available only for, let's say, Android users on 6 and higher. You can basically make the whole application available only to them. And the second disadvantage, imagine someone, let's say, access the application from another device and they reset the password. Well, the original device doesn't know that the user reset the password. So either way, when the user session expires and they will try to log in with biometrics, we will get their old credentials and send them to the server, which means the request will fail and the user has to input the credentials again. It's something basically what the user should expect if they reset the password, but you as a developer obviously should kind of understand that this behavior will happen. So let's go to the second implementation, which is the backend implementation. And here, don't get scared, I have a diagram that I'm going to show. Pretty much we're going to be talking about RSA algorithm when we will create a private and public key, which can kind of, one can sign something and the other can verify that it's correct, that it's true. And let me show you the diagram now so that we are on the same page. So in this particular implementation, by the way, it was official implementation from Google, even though a bit older, they suggested the device creates two keys, the private and the public. The private one is securely stored on the device, and the public travels to the backend, and the backend basically saves it in a database under the specific user and specific device, because obviously a user can have multiple devices. In practice, what happens then is when a user's session expires, so we will again prompt them for biometrics challenge, and then with the private key, the device signs piece of data, like let's say some simple string, and this string and the signature is sent to the backend. And the backend then verifies it with the public key, and basically, because the keys are paired, the public key can understand if it was really signed by the private key and understand that, okay, this is the device I expect the data from. And then when the backend approves it, basically, we can do some action. In case of the login authentication, the backend will return access token for the user to access the application. But you can imagine using this methodology also for other use cases, maybe approving a transaction and such. So let's go to the advantages of this. The biggest advantage, in my opinion, is extra layer of security. Actually, when I chatted with my backend colleagues, they even proposed more safer solution when we can actually create the key pairs on the backend, and then the mobile device just requests the public key, and actually the key pairs are created just for one-time use. So you don't have to even associate them with a particular user or device. It's a similar process, but the creation of the keys happens on the backend. Maybe safer than doing it on a device. And then this approach, as I mentioned, can be reused for other authentications. As I mentioned, transaction approval can be one of them, which is good because obviously this will save resources in the future to have something that you can reuse. The disadvantage, probably clear, is that we need backend resources. It's not always the case that we can afford the backend resources, or that we have a skilled backend engineer that can, let's say, implement it. It definitely means longer delivery time of the feature, and yeah, we saw that basically implementing this both on front-end and backend will result in more engineers needed. So maybe not something for the cost-sensitive clients, but if someone needs a secure solution, maybe this is the way to go, and definitely no time to save money. Finally, the other disadvantage, something I touched on previously, while the solution is readily available in React Native ecosystem, it's not providing the best user experience. Now I'm talking about React Native Biometrics library, which pretty much applies this concept, but the last commit, last change to the library was 2 years ago, so they are falling behind on the biometrics term. I believe they cannot offer you, for example, fallback to passcode when the Face ID doesn't work, which is not ideal in the kind of environment that people wear masks and such. So that's something we have to consider. And if we still want to have this solution, that means we need to use two different libraries. I can personally recommend it's for local authentication for the biometrics part, and then you can find maybe something like React Native RSA native for the RSA algorithm. But here you have to be sure that whatever the RSA native library signs with the RSA algorithm is verifiable with your backend implementation, because personally I had some issues with this. I tried to verify the signature from this library on the backend, didn't have much luck. Maybe you will have more, or maybe you can find other alternatives to this library. But again, here we are talking about more custom solution, so we are getting again into the disadvantage that the costs will kind of increase because you have to do it on your own. So let's go to the final implementation, the combined implementation. Personally, I feel this is very pragmatic approach, combining the two previous implementations. The flow is very similar like with the credentials, but instead of the username and password, we are storing a refresh token securely on the device. The refresh token basically comes from the backend, and it allows us to refresh the user session. So when the session expires, we just retrieve the refresh token, which is hidden behind the biometrics, and we send the refresh token to the backend, and the backend, the particular endpoint, will return access token to the user, and the user can use the application again. So the clear advantage of this is that if the backend already utilizes the refresh tokens, basically we don't need any work on the backend. The frontend can implement it easily themselves, quite quickly. The second advantage is we don't store sensitive credentials on the device like username and password. And the backend verifies the refresh token, which gives it some security aspects we saw from the second implementation. And finally, this solution, again, it's really available. We just need to store this refresh token securely, either in a keychain on iOS or on Android in the key store. The disadvantage of this, well, hard to find some, but the one I would mention is that there is only a single purpose for this approach, meaning that we can just refresh the user's credentials in the session, but we cannot use this approach to approve, let's say, the transactions and such. So this implementation is very pragmatic. If we are already utilizing refresh tokens, there is no backend needed, which is super great for a front-end engineer, and you can implement this relatively safe solution quite quickly. And those are all the solutions I wanted to mention. So we will just summarize now the presentation with something I found interesting, the UX guidelines. Actually, I want to chat about specifically Apple guidelines because they have really nice document about it. I found them slightly provocative because they're very strong, let's say, positions from Apple, how it should be implemented, and yourself, you will not find always these guidelines kind of fulfilled by mobile applications. So the first one, Apple actually says, whenever possible, support biometric authentication. And then they add, avoid offering a setting for opt-in to biometric authentication within your app. Meaning, let's say you go to a profile of your application and there is a checkbox and you can click enable biometrics. So Apple is telling you, do not do it. You should assume that if the user is using on their device biometric authentication to unlock it, let's say, you should already make the user start using the biometrics within your application. That's quite aggressive, I would say, because oftentimes you will find applications asking the users, do you want to enable biometrics for this application? You will see often the setting in the profile section. So it's definitely a topic for a discussion, I would say. And then another guideline is present people with a single way to authenticate and use fallbacks. This means that when we expire the session, we saw two different buttons, right? Login with biometrics or login with credentials. Apple basically tells you, hey, if the user is already using biometrics, don't offer them the credentials as an option. Just make them use the biometrics. And if the biometrics fails, their Face ID is not working or the passcode doesn't work, then you could suggest to them, hey, use the credentials. Then they have to input the username and the password. So that's again quite questionable because imagine a user is basically based on the Apple guidelines, they opt in for the biometrics for the application before even they decided to, and then when their session expires, the only option you should show them to is to log in with biometrics. So maybe some users might be surprised. But if I go back, maybe I would just mention, I think this is a way of Apple to kind of educating users to prefer biometrics, maybe just to push some users that are not used to using it, so that they get used to it, because at the end, the biometrics offers them the best user experience. And that's why they probably try to push them slightly with these guidelines. The next one is initiate authentication only in response to user action. That means that they should click a button, hey, I want to log in with biometrics. Also not something what I would say you see, because for example, when your mobile banking application expires your session, maybe they will prompt biometrics challenge on you immediately after they recognize that your session expired. They will not let you click the button because they just want to streamline the experience and get you back to the application as soon as possible. But obviously, if you are utilizing Face ID, maybe at some point you don't want to have your Face ID scanned by the device. That's why they probably suggest this. The next one we touched on at the beginning, so identify the authentication method. You should definitely say to the user, hey, you are signing in with Face ID, you are signing in with Touch ID, so that they know what to expect. And the final point, they actually mention the applications shouldn't be using the icons to identify system authentication features. That means icon for a fingerprint or icon for a Face ID, because they think that maybe some users get confused. They see a Face ID symbol, so they might think that the application, let's say, is already scanning their face or something. So they try to kind of discourage you to use these icons. But in some applications, you can actually see them quite often as well. And that's all. Here is the link to the guidelines if you want to have a look yourself. And this is pretty much everything from me. So thank you for your attention. I will definitely now give you some time for questions, and together we're done, we will answer if we get some.
I'm coming back. All right, thank you very much, Aron, that you shared the experience with us, and I believe that was very insightful and thoughtful. So there are people that gonna save time and maybe headaches too because of your research, and it will be a bit easier for them to pick the right option that's gonna suit their needs. I'm checking the chat. We still have several people online, but there's no question yet. So let me take that time and do a quick promo, because next week we'll be also hosting another event, another Frontend event on Thursday at the same time, 6 p.m. Prague time, and there will be Michal Jarnot talking about state management. So definitely tune in. You can find the event on our website, strv.com/events, and there's a link to Eventbrite, and you can sign up there. As well as there's another section on our website, /careers. So as Aron mentioned, take it, give it a look, and if you find that content interesting, as well as this content interesting, me and my team will be more than happy to talk to you and have a chat and eventually find and join our path. Still no question. This is being live streamed, so there is a way for everyone to ask their question on YouTube, but this will be also recorded and shared on our YouTube channel afterwards. And I guess that if there's no question at that point, feel free to hit up Aron on his email or through our website, and we'll be more than happy to talk to you. Oh yeah,
Just some promo.
just a promo, more promo. I think that's enough of promo of today. Maybe see you next week or the other time. Bye bye.
Okay. Bye bye everyone, and thank you for your attention.